Okay, so let's look at part A. Okay. So part A is to calculate the initial current in each branch of the circuit. There are 3 branches, so all the current are leaving the nodes. So there's only one node. These 3 points are the same nodes. We talked about this last week. So all the current IC plus IL plus IR equals to 0. Add them together. Okay, so IL is known, right? We know the inductor initial current. We know this one is negative 0.3. We already know that. And we can know this IR. So we know the initial voltage here is 25 across this capacitor, okay? So the same voltage across the inductor and same voltage across the resistor. So the IR will be this voltage divided by the resistance. So to do that, we can calculate that IC is actually just equals to 0.1 amp. Okay, so all the 3 are known. All right, so the next part is part B. Okay, let's talk about how to calculate the voltage VT here. Okay, so this is a second order circuit. We have a procedure to do that. First, we want to use we're going to use this equation sheet from the final exam. You're going to have this one for you. So we're going to tell if this is a parallel or series. If these two, especially these two, okay? So they are parallel. So we're going to use this side of the equation, okay? So we're going to have alpha equals to 1 over 2 RC. You get a plug-in number. R is 125. C is 5 multiplied with 10 to the order of negative 6 microfarad. Then if you calculate that, alpha is 800. And if you do the same for omega naught, omega 0, that's 1 over LC root. So L is 200 multiplied with 10 to the order of negative 3 multiplied with 5 multiplied 10 to the order of negative 6 and 1 over it and square root of that. If you do the math, you got a 1000. You can see that alpha is larger than omega naught, so alpha, so you write like that. So alpha square is actually, smaller than the omega naught square. So we say this is under damped. Okay, then we're gonna use this equation for underdamped. We're going to use this equation for underdamped. All right. So the next step is we got to plug in numbers for the specific part. Okay. So if you plug t equal, so when t equal to 0, which is the initial state. For initial state, we can simplify it a lot. So xt here, we actually using vt, right? And when t equals 0 is we are doing v0. So when t equal to 0, this is still vf will be, we'll talk about that later. So this is actually the voltage at the final value. Okay, let's look at that first. So final value for this voltage, how much is that? All right. Initially is 25, and there's no source. So in the end, we say steady state when time is infinite, then this inductor become a short circuit. So when it is short circuit, the voltage definitely be 0, right? So this one we know is 0. And if you plug t equal to 0 here, you can see the whole so the whole term for sine t equal to 0, sine 0 is 0, so b is gone, b2 is gone. Okay, when t equal to 0, e to the order of 0 is 1, so this is gone. So what we left is just b1. Okay, it was this one plus b1, but the final value is 0 here, so it's just b1. Okay, so v0 is b1. And the next side of equation we can use is the dv0 dt. Okay, so again, this 1t equal to 0. So we use this one. So 1t equal to 0, we can plug in t. So you can see this term is gone. This term becomes 1. Okay, so b2 omega d has been left. So if we collect terms, you're gonna do that in your time. So I gave you the answer. So omega b1, negative omega b1 plus omega d b2. Okay, so now the right hand side of the first equation we got a b1, the second equation we got this. Okay, in this case, we're gonna find out what's the initial value for V. We know that easily is 25, so B1 equal to 25. So we also want to know this. It's a little bit tricky here. So how to get this? So dV0, let me show the diagram here. So dV dt is actually equals to, if you find the IC, the capacitor current definition, the capacitor current is C dV C dt. Okay, so dV dt, VC here is the same as this VT because they are the same voltage, right? So this voltage is just the same as this voltage. Okay, so dV dt just equals to IC over C. Okay, so and when we plug in t equal to 0, we put a t equal to 0 here as well. So this whole thing, dV0 dt just equals to IC0 over C. And we know from the first question IC0 is 0.1 amp, and C is 5 multiplied with 10 to the order of -6. So we know that this is 20K. All right. So we can now plug this in here, and alpha, we know alpha is 800, we know omega d is 1000, and we know this equation equals to 20K. Then we can easily find B2 equals to 66.67. all right, so finally what we're looking for is VT is this equation, this whole equation, right? So all this two step, what we do is try to figure out how much is a B1 and a B2. We're using two initial conditions. First is in time domain, v0. Another one is the derivative of v0. Okay, that's the derivative of vt, and we put t equal to 0 to simplify it to this one, and at left hand side we use the capacitor current to find the value for this one. Okay, a little bit long, so hang on there. So vt, let's just use this one. Okay, x final is 0, so we just skip that. We're gonna plug in b1 is 25 e to the order of negative alpha t multiply with cosine 600t, so cosine omega dt. Alright, so I find the problem here is omega dt. Okay, it's not omega 0t, and we haven't calculated omega d yet, so omega d is right here. Okay, omega d is right here, so we can calculate that omega d is so omega 0 square minus a alpha square root, got is 600. All right, so this is actually 600 omega dt, and we're gonna plus b2. B2 is 66.67 e to the order of negative 800t, and sine 600, which is omega dt. Okay, that's the whole expression. Unit is volt for this one. All right, let's stop here. All right, so before we talk about part C, there is a error, mistake. This is omega d. Okay, same thing like here is omega d, not omega 0, so this should be 600. Okay, should be this 600. If you plug that in, you will get this one. The result is right. Okay, all right, so the last part C, to calculate ILT. Okay, so we can actually start from this one. So this is still true. IC equals to IL plus IL plus IR equal to 0. But what we did here is when t equal to 0, these are three constant numbers plus together equal to 0. So we find the initial current for the capacitor. Now we are looking for ILT. Okay, is a time dependent variable. So if you put them all in terms of t, so you can see this is a constant. It's still the same thing, but this is actually changing. And if we can, I can rewrite that ILT, what we're looking for is actually equals to negative ICT minus IR. IRT equal to IR is a constant. Okay, so the only thing we don't know is ICT. Okay, so how to get ICT? We had it here. So ICT is actually C dV dt. Okay, so I will write it again here. So ICT, so part C, equals to C dVCT dt. And this VC is just this V. We talk about that, right? So the V across all the components are the same. So we're gonna do the derivative of this one, of this equation. I'm gonna do a derivative of this one. It's a bit challenging. There is something we need to know before we actually dive in. We can first make it a VCT as a symbol so it can be easier to calculate. So we can bring it back. So this is A1. We give a name for that. E to the order of negative alpha t. This is a cosine omega dt plus this is A2, another number, or B1 or B2. You can use that as well. So I use A1, A2, just try to match Kenny's notes. So this is negative alpha t cosine, this is sine omega dt. Okay, we make it this way is easier to recognize later. So we're gonna use derivative product rule. So the rules look like this. So the derivative of something, for example, fx gx is one function multiplied with another function is equals to, you keep it the same, make a derivative of the second one plus you take a derivative of the first one and keep the second one. Okay, that's what we're gonna do. So you can see here, this is, change the color, this is a constant. You can think this is the first function f of t. This is another function g of t. We're gonna do this derivative first, and then we will do the second. Okay, so let's do that. For the first part, we're gonna do this one first. Okay, so VCT equals to A1 is still A1. Let's do this term first, okay? Make a derivative of this one, A1. Oh, no, sorry. We're gonna do this first. So keep this e to the order of alpha. I just don't know how to write alpha. Alpha t, keep the same, so fx is the same. Gx, to take a derivative of that one, become a negative sine omega dt. Okay, and thinks this is another function, so you're gonna do that derivative of omega dt again. That will be another omega d term here. All right, we done the first part, and then we do the second one. So we're gonna plus A1, this one, do a derivative. Okay, then you're gonna have a negative alpha at the front. You're gonna multiply the negative e to the order of negative alpha t. Okay, sorry, this is the alpha. Okay, this is the alpha. And I need to scroll to the right. Need more space in. What's next? Next part is cosine, right? So the cosine omega d, you just copy down. Yeah. All right. We did that for the first term. We're gonna do this for, because they are linear, so we can do it one by one. Then now we're gonna do this one. Again, we're gonna keep this one the same derivative for this one, and then we're gonna do a derivative for this one and keep this one. All right, so I'm gonna start with A2 e negative alpha t, keep that, and cosine, take a derivative, becomes sine omega dt, and there is omega d, and then we're gonna plus A2. We're gonna do the negative alpha e to the order of alpha, negative alpha t, and then the rest keep on changed. Okay, so that's the whole thing. All right, and if you collect terms for this one, you can pause here and try to collect terms. You will find the result, and you're gonna collect terms and plug in A1 and A2. So plug in A1, A2, omega D, and collect terms. So in the end, you will find the result. So the result is this one equals to 20k e to the order of negative 800t cosine 600t minus 68333.33 e to the order of negative 800t sine 600t. Okay, so that's let me shrink a little bit. That's VCT. Okay, and we're almost there. Okay, we got this so this one, what we always down is actually dVc dt, right? So VC is this one, and what we did is a derivative of that. So finally we are looking for VCT, which is C multiplied with dVc dt. So what we need to do is multiply with a C in front of all this. Okay, and after that you can just minus the IR. Okay, then you will get the result. So IR is equals to V. It's actually the same VCT or VT, right, divided by R. And VC, you don't need to derivative, that's so good. And that's just this one. Okay. And you're gonna collect terms with it. Alright, so I copy paste the final result. So this one multiply with the C. C is a small number, so it's become this one. And IR is the original VCT, is what we got here, is this original one, divided by that 125, the resistor, we got this one. Okay, so if this one IC gonna be a negative IC here, IR is negative IR here, so this negative 100 and negative 200 become negative 300, and these two combined look like this. Okay, so that's the whole process.